Hey there, today's lesson we're looking at linear and non-linear functions. So linear functions represent a constant rate of change. Remember, that was our k value several lessons ago. That constant rate of change is often referred to as our slope, y over x. And so when you divide y over x, it stays the same. It has to be a constant in order for it to form any kind of line. If it's not a constant, then you might get something curvy like that, which is an exponential kind of function. You might get something erratic like this. I mean, who knows what you might get. But a constant function, or a constant rate of change, is going to form a line, making it linear. If it's not constant, then it becomes non-linear. Okay, so you find that out by looking at patterns and things like that. The rate of change for nonlinear functions is not constant. That is, the values do not increase or decrease at the same rate. You can use a table to determine if the rate of change is constant. And that's really all today's lesson is. They're going to give you a table, and you're going to be looking at the x value and the y value and deciding, is it changing at a constant rate all the way throughout. And so when you look at the first one here, we can see that going from 3 to 5, it's an increase of 2. 5 to 7 is an increase of 2, 7 to 9 is an increase of 2. We know that part's constant. So is the y constant. 7 to 10 is adding by 3, 10 to 13 is adding by 3, and 13 to 16 is adding by 3. As long as that's going to be the same, we know we're in good shape there. This indeed would be a linear function. You could graph that and it would make a nice line. Okay? This next one, we see on the x value, we're going increasing by 1, increasing by 1, increasing by 1. Looks good. Over here, decreasing by 1. Nothing wrong with decreasing, that's fine. And then here, we are going down we are decreasing by, gotta look at the right thing. From 3 to negative 6 is a decrease of minus 3. But to go from minus 6 to minus 10 is a decrease of 4. Those do not equal, so that means that's not the same rate, is it? And here, from 10 to 15 is a negative 5. So again, none of those are equal there. So because these numbers here don't match one another, we can say this is not a constant rate of change. It therefore is non-linear. So if you graphed it, it wouldn't actually work out too well. All right? So you'd end up with something a little funky. I don't know if I can, I probably can't do it there. All right, so let's take a look at some other examples. So what you're going to have today is you're going to have some tables like this. So look for the difference. From 3 to 5 is plus 2. 5 to 7 is plus 2. 7 to 9 is plus 2. So we know we're increasing by 2 in the top. That all looks great. So here, 7 to 9 is plus 2. 9 to 11 is plus 2. 11 to 13 is also plus 2. Because those all match, and those all match each other, we're going to say this is definitely going to be a linear function. The next one, 1 to 5 is plus 4. Nothing wrong with that. 5 to 9, plus 4. Nothing wrong with that. 9 to 13, plus 4. All looks good. So we're doing the same amount of increase from one to the other. 0 to 6 is plus 6. 6 to 8, though, is plus 2. 8 to 9 is plus 1. These, though, don't match each other. So this will become a non-linear function. And that's really all we're doing today. You can have some negative ones here, right? Going down that's subtracting by 1, subtracting by 1, subtracting by 1. That's okay. Here, from negative 1 to negative 5 is a decrease of 4. From negative 5 to 9, wow, that's going to be an increase of 14. And 9 to 8 is a decrease of 1. Like, that makes no sense at all. So this is going to be a non-linear function. It's okay to have decreases. Nothing wrong with that at all. You can go down, right? Your graph can go up and your graph can also go down. Nothing wrong with that, but it needs to be constant in order to have a constant rate of change, a constant k value, that constant slope, so that it actually is a line. Otherwise, it doesn't quite work. Okay, so you're going to have a few tables to look at today and just decide, are they linear or non-linear? Let's come back and check those in just a minute. Okay, looking at linear, nonlinear. Okay, so here we can see we're increasing by 1, 1, 1. And over here we're increasing by 4. 12 to 16 is 4. 16 to 20 is 4. So that is going to indeed be linear. Here we're going 2, 2, 2. So that's all good there. Here we're going down 2, going down 3, down 4. So that is going to be nonlinear. Right? It is a pattern, but it's not linear. Number 3, we're going down 2, down 2, down 2, no problem. Here we're going up 4, up 4, up 4. Doesn't matter if one's down, one's positive, doesn't matter. At least it's consistent. That's the same, that's the same. This is going to be linear. Here we're going down 2, down 1, down 2. And this is staying the same, the same, the same. Because these are all different, this is going to be non-linear. Okay? Well, I should say sort of. Let's take a look at this one. What if I graph this one real quick? Alright, so here's a point at 7. Here's 7. So when x is 3, 1, 2, 3, y is 7. When x is 1, y is 7. When x is 0, y is 7. When x is minus 2, y is 7. Do I have a linear function? Well, in reality, I do have a line, don't I? It's going to be a line all the way across there. So no matter what value of x, y is equal to 7. So technically, I would say this is going to be linear. It's just a little different than we normally would say because it doesn't follow the pattern. There's no change in y. Y is always equal to 7. Okay? So yeah, we probably would say that's a linear one, just not the normal. Okay, here we're going to be down by 3, down by 3, down by 3, up by 5, up by, in this case, 5, up by 5. So that would be linear. Here we go down 1, oh sorry, go up 1, up 1, up 1. And we go negative 2 to 0 is up 2, up 2, up 2. So that's linear. 1 to 2 is plus 1, plus 1, plus 1. 5 to 7 is plus 2, 7 to 9 is plus 2, 9 to 11 is plus 2. So that would also be linear. And negative 2 to 0 is plus 2, 0 to 2 is plus 2, 2 to 4 is plus 2, 0 to 1 is plus 1, 1 to 3 is plus 2, 3 to 9 is plus 6. That doesn't match, so this is going to be non-linear. So that's the idea today, just kind of graphing them out. If you graphed them, you would see a line. The only kind of weird one was number 4, which again, based upon the chart, you would probably say nonlinear, but if you graph it out, it's going to make a line, so that is a straight line, just a little odd. Okay? All right, that's it for today. Have a great day. We'll see you next time.